So in this video, we are going to look at Hess's law and how to use Hess's law to determine the enthalpy of a reaction. And so we've got four ways that we can calculate the enthalpy of the reaction: average bond energy, calorimetry, enthalpies of formation, and then today's video is on Hess's law. Remember, a negative delta H value is favorable. So Hess's law states that the change in enthalpy is the sum of the changes for the individual steps in a reaction. So think back to kinetics. We learned in kinetics that most reactions do not go directly from reactants to products. Instead, they have elementary steps which add up together to equal the overall reaction. All right, so Hess's law takes into consideration the individual steps that are needed for a reaction to occur. And Hess's law will be the change in energy. So let's calculate the delta H for the following reaction. So here is our overall balanced equation. Carbon dioxide gas, 2 moles of it, plus oxygen gas yields 2, did I say dioxide? Let me start over. 2 moles of carbon monoxide gas plus 1 mole of oxygen gas yields 2 moles of carbon dioxide. Now, this is a two-step process, and so the elementary steps have been provided below with the delta H value of each of those processes. Now, you'll notice that carbon monoxide becomes solid carbon and oxygen gas, and then this carbon and oxygen gas become carbon dioxide. So, how are we going to do Hess's law? All right, our carbons cancel out. Our oxygens, check this out. I have 1 oxygen as a product and 2 oxygens as a reactant. So I'm going to remove 1 oxygen from the reactant side to give me overall 1 oxygen as a reactant. Now, my delta H value is just simply the sum of these two parts. So the delta H for the first reaction, or first elementary step, is 221 kilojoules, and the second elementary step is negative 787 kilojoules. So when we add those together, we get negative 566 kilojoules. So let's look at the same overall reaction, but let's look at the individual steps. Notice my steps have changed. I have provided for you the second step in terms of an endothermic reaction. All right, so we have to be careful here. All right, we have to flip this reaction in order to get our reactants and products to cancel out in order to match the overall reaction. So it's very common that our delta H values are not necessarily, and our our elementary step is provided to us in the opposite of what we were given, like all positive or all negative, for example. So in this case, you have to pay attention. All right, that's a common thing that will give it to you, all of them positive or all of them negative, and you have to make sure that they are in fact negative or positive the way they are provided. So what I'm going to simply do is I'm going to flip this equation. So my reactants, carbon dioxide, become my new products, and my products become my new reactants. And because I flipped the equation, I flipped the delta H, because if the forward reaction is positive, the reverse reaction is negative. And then we can cancel out and add together.